Thank you very much. My name is Arun Gupta, and we will talk about container orchestration platforms on Amazon Web Services platform. I do intend to show a lot of demos in this, and my goal today is to talk about what is the need for orchestration platform, kind of briefly covering it, and then right away jump into what are these different orchestration platforms essentially, and how do they operate in the AWS infrastructure. At a very high level, if you look at sort of how your Docker workflow looks like, you got a client, you got a Docker host, and you got a Docker hub or a Docker registry. In the Docker registry, this could be a public registry, which is by default hub.docker.com, or this could be a private registry or a managed registry like Amazon ECR or EC2 Container Registry. It could be inside your firewall, outside your firewall, set up on a VPC, whatever way you want to set it up. But essentially, that's sort of your repository where your images are stored. You can download those images from the client, but the client doesn't download them directly. The client makes a request to the Docker host, which then downloads the images and runs the containers. Now, in this case, I'm showing a single host, but typically, that would be good for development. But when you go into production, then you have a multiple hosts. And those hosts, or the cluster of those hosts, may not be completely homogeneous. In the sense, some hosts may have different capabilities, SSDs, more memories, more CPUs, and stuff like that. And even if this is a homogeneous cluster, how do you figure out where these containers going to run? And that's what is basically defined by your container orchestration platform. If you want to run a multi-container application, like take an application, it's got a database, application server, a web server, a caching server, and multiple instances of those running, so you got a lot of containers running. Where do you run those containers? Which host do you run those containers on? And that's essentially what is done by an orchestration framework, okay? Now, the four primary frameworks, so to say, that we're going to cover today is Docker. Well, of course, Docker is the primary way by which you build your images. So Docker is one. Then we're going to take a look at Kubernetes. We'll take a look at Amazon ECS. And we'll take a look at DCOS by Mesosphere. So my intent is in the next 55 minutes, I'll give you a complete deep dive, not complete deep dive, but a good introduction to what these platforms are and show a working cluster for each one of these. All right, let's get started with Docker. Now, if you want to get started with Docker, what is the easiest way to get started? Docker comes in two varieties. There is a Docker Community Edition, and there is a Docker Enterprise Edition. You can go to docker.com, and the website pops up. The website shows you how you can download the Community Edition versus the Enterprise Edition. Now, in the Community Edition, there is, of course, Docker for desktop, like a Mac or a Windows, and you can run it over there. Then you have Docker for server, so like any of the Linux boxes. And then you have Docker for AWS or cloud, or Docker for AWS and Azure. So those are sort of the three options over there. To make it more confusing, there is a stable versus an edge build. Edge is a bleeding edge build, and stable is a build that is released every 3 months. So depending upon how stable or how cutting edge you want to be, you can choose. Let's say on my case, I'm running Docker for Mac. I'm using the edge build because I always want to have the latest bleeding edge features in my Docker environment. Similarly, for Docker for AWS, I can say, okay, I want to spin up Docker on AWS. I want a stable or an edge build. So those varieties are there, okay? And then Docker EE is basically their commercially supported version. Now, if you were to spin up a multi-node cluster, typically when you are setting it up on Amazon, you would not run a single node. You will run a multi-node cluster. When you are spinning up a multi-node cluster, what you would need to do is, I'm going to initialize my cluster. I'm going to say Docker swarm init. So that starts up my cluster, and you specify what the listen address is going to be. Then you can have a worker join the cluster. Manager is from the administrative perspective. Worker is where the containers are run. So I can have a 2-node cluster in this case. I can have more workers join the cluster as well. So depending upon, I get the tokens from the manager, a worker token or a manager token, and which token I use to have the node join the cluster. It becomes a manager node or a worker node. I can certainly have a multi-master node as well, a multi-master cluster as well, in which case I got 2 managers, and in this case, if you can see specifically, there are 5 workers. Now, the request can go to any of the managers, and it is automatically proxied to the primary master at a given point of time. Now, this is a good development environment if you are trying to do things on your own. I mean, you can do this on a MacBook as well, and there are ways to do that. So for example, you can spin up multiple Docker machines, which are nothing but VirtualBox VMs, and you can simulate this environment on your MacBook. But if you want to run this on AWS environment, how do you do that? For that, we actually have Docker for AWS. Docker for AWS is nothing but a CloudFormation template. And essentially, if you think in terms of AWS, CloudFormation template is an automated script which says, tell me all the resources that needs to be created and how those resources need to be linked and talk to each other. So for example, when I'm creating a Docker cluster, I need to spin up 4 nodes. On those nodes, I need to install Docker. I need to make sure I run those commands, Docker swarm init. I need to make sure I obtain the tokens. All of that processing is done automatically for you as part of the CloudFormation template itself. And the beauty of this is, when Docker worked with Amazon on this, Docker for AWS, it leverages full AWS infrastructure. Well, not full, but at least it's got a good integration with the AWS infrastructure. So for example, when you spin up your Docker worker nodes or the manager nodes, those are configured in an auto-scaling group. What does that mean? That means if a node goes down, because it's configured in an auto-scaling group, it'll automatically come back up, so that you are resilient to node failure, for example. It is also configured with the elastic load balancer. What that means is, if in your Docker cluster you're running a service and you make a request to it, it'll go to the ELB, and then it can do the load balancing for you automatically. It is also configured with EBS. So if you want to create your persistent volumes, it can actually store them on EBS very easily. So in that sense, you can see there is a nice integration with the AWS primitives, and then it works out of the box for you. Okay? So let's see how we can get started with this. As we said, Docker comes in 2 varieties. There is a CE version and there's an EE version. And within CE, there is again a stable versus the edge release over here. Make it more interesting, you could use your own VPC. So let's say you have set up your own virtual private cloud in Amazon. You can say, set up this Docker for AWS in my VPC, or say, I don't care. I don't know what VPC is. Just build something for me. I want to get started. Then you can say, go with the defaults. So one thing that is good about the CloudFormation templates is how you can take a lot of defaults just to kind of dumb the process for you. Okay? Before we jump into Kubernetes, let's take a look at the Docker cluster now. So what I'm going to do is I'm going to go to docker.com here. Okay, here it says get Docker Community Edition, get Docker Enterprise Edition. I can go to the Community Edition, for example. If I go down, you can see it's nicely distributed. There is Docker CE for Mac, Docker CE for Windows. So you can see that those are your desktop versions. If you want servers, it's got a few varieties of the Linux flavors as well. And then similarly, you can see for the cloud. This is for AWS and Azure, okay? If I want to get started with AWS, I will click on this link, launch stack from Docker Store. It takes me to Docker Store where any vendor can publish their applications over there, and that's how Docker is doing it as well. It kind of gives you more details over here. Now, one of the things you need in order to get fired up for Docker for AWS, it does create a few resources for you in the background. So you need to have certain privileges and permissions and IAM roles, all of those to be ready for you. And I think if you look at the documentation here, it talks about what those requirements need to be. But if you want to get started, this is a stable build, this is the edge build. I can click on the stable here. And as soon as I click on the stable here, it actually redirects me to my AWS console. And it says, okay, you're ready, and let's fire up the CloudFormation template. In the CloudFormation template, of course, it says design a template. You can choose a template. The URL is automatically populated for you. And on the top here, you can see my zone is Northern California. That's where I live. You can go to next here. You can give it a stack name. Let's, for the fun of it, I will just say call it GIDS, for example. Now, in the CloudFormation template, the approach that I like here is you have to specify the minimum number of parameters, which is very compelling. I can define the number of managers that need to be defined. By Docker's recommendation, it needs to be 1, 3, or 5. They always want you to recommend to choose odd number of workers. That simplifies the leader election in case there's a network split somehow. So let's choose 3 here, and I'm going to choose a number of worker nodes. So essentially, this will be a 8-node cluster. Now, I can choose which SSH key I want to use in case I need to have the access or the ability to SSH into a particular node that is created for me. Because end of the day, these are all EC2 instances in the back. Okay? I can also do the integration where my logs for my services are automatically redirected to CloudWatch. Or I can say, you know what, no, I don't want to do that, and then I can disable that feature. Then, of course, I need to choose the instance types. So you can see the full range is available depending upon how many containers you need to run. You need to do the container sizing for your application. But that's when you choose what is the manager instance type. Similarly, you choose the worker instance type. Now, manager by default can run workers, or you can say, you know what, I don't want to run any workers on the manager. Make it a manager only. And that option is not configurable here. But when you're doing it the command line, you can do that. Okay, so once we make that selection, I can click on next here. Take the defaults here. If you have a pre-configured IAM role, you can choose it here. And on this page, it kind of gives you all the options that you have chosen. Here is the template URL. Here is, I'm using the Docker 1703. This is my stack name. This is my swarm size. These are my swarm properties. And if I click on this box here, and then I say create, it's going to create a cluster for me. Now, I'm not going to create the cluster right now. I literally created a cluster this morning, or I think yesterday. Let's take a look at it. So let's cancel it here. This is the cluster I created, essentially. So now I got 2 clusters here, but let's talk about the first one here. So I look at Docker here. It says create complete, and this was done late night yesterday. So if I look at Docker here, you can see sort of all the details here. I want to see the complete log, for example. So it shows all the events. And in the events, you can see it's configuring ELB here, is putting the policies in the Dynamo database, is putting manager into an auto-scaling group, is putting the workers into an auto-scaling group. So you can go through the entire event log to get more details, okay? Or you can look at outputs here, and then it'll tell you some other values that are relevant for you, okay? Now, if I go to the EC2 part here, I'm into my Amazon console. If I look at the number of running instances here, I have actually pre-set up cluster for all Docker, Kubernetes, DCOS, and ECS. So you'll see a lot of instances here. But what we can do is we can sort it, first of all. And then here, you can see this is my Docker manager. This is Docker manager. This is Docker manager. So I got 3 Docker managers here. So for example, I can say name. And we can say, no, not the key name. We just want the name here. Name. And then we can choose Docker, for example. So it will show me only the Docker nodes here. So this is a very standard AWS console. And now I'm looking at only my Docker nodes that are created for me. Now, you have done your development using Docker for Mac, and you have your compose files ready. You have been downloading images from Docker Hub. That's all working good. Now you want to take that into production. So what you do is, with this Docker for AWS, you set up a SSH tunnel. And once you set up SSH tunnel, then you configure your CLI to point to the Docker manager. And once you have configured it, then you can start deploying your applications to the Docker for AWS. So the transition from running on your laptop to rather running in the cloud is very easy. And AWS definitely gives you that level of scalability that we care about. All right, that's a quick overview of how to get your Docker cluster running up in AWS. Switch gears. So the second orchestration framework that we're going to look at today is Kubernetes. Okay. Oh, we're not plugged in yet. So we understand Docker. The Docker is the container format, the image format, the runtime format, whatever you may want to call it as. So Kubernetes kind of begins there. Kubernetes says, hey, yes, Docker is one of the formats, but there are other formats like Rocket, which probably a handful of people in the world use. But essentially, Kubernetes is a container orchestration framework, which is saying that, okay, we can deploy any container format, be it Docker, be it Rocket, and when OCI, which is the Open Containers Initiative, brings up their container format, which is a standard format, then we can support that as well. But essentially, the basic unit in Kubernetes is called as a pod. Pod is nothing but a collection of Docker containers put together that needs to sit down together. And don't think of that in the terms that, oh, my database and my application server need to talk to each other. They should be in the same pod. Think of it from the perspective that what is the most logical unit? How can you break your application? The units which need to scale independently. Typically, your database would scale very differently from your application server and so on and so forth. So what you would do is, if you have a classical 3-tier application, then you will have a web server, an application server, and a database server, and those would be living in 3 different pods. Now, take a classic example where your application server, or rather the application deployed in the application server, needs to talk to the database server. Now, because the database server is running as pods, those pods, if they get terminated, they can be rescheduled on a different host. So they will be given a different IP address. And that's the property where the container gets rescheduled on a different host is called as being ephemeral. So what that means is, from your application perspective, your application cannot rely upon the IP address of the pod of the database container. So for addressing that, Kubernetes has this concept of a service where you can define a logical name over the pods. The service identifies the pods that belong to it using labels. The pod comes up, it says, hey, I got this label. When a service comes up, it says, I'm looking for pods with that label, and then there is a match. And these labels essentially are stored in a distributed watchable registry that is part of Kubernetes itself. And last but not the least, you have this concept of a replica set where you're saying, oh, you know what? I want the ability to scale the pods. I want to scale the number of web servers that are running in my application. So let's wrap them in a replica set, and then I can say, run that many replicas of that particular replica set. That's from the developer perspective. Those are the key concepts here. Now let's take a look at it from the ops perspective. Well, end of the day, I need a machine or a VM where the cluster needs to run. It could be a one node cluster, or it could be a multi-node cluster. The first node in the cluster, just like Docker, has to be master. The master which basically understands what your cluster looks like. It is responsible for creating all those resources. It is responsible for listening to your client requests. When a client makes a request, from the client perspective, which is kubectl, it makes a dumb request. Oh, you know what? Create this resource or take this configuration file and create the resource. But underlying what happens is the REST API goes to the Kubernetes server or the master, and then it creates the resources. So that's what the API server is for. And then there's a worker where the actual containers are running. On the worker, what you got is a kubelet, which is sort of a node agent, which is listening for requests from the master, and then it does the right thing on the node itself. Now, these the workers are monitored by systemd or monet, depending upon your operating system. So at a very high level, if I were to look at sort of the Kubernetes architecture, I have a master with these components over there. kubectl is the CLI that talks to the master, says generate these resources. The master then says, okay, I gotta look at the workers that are available in my cluster. Then I'm gonna go talk to the kubelet. Once I've identified, applied my orchestration algorithms and the scheduler algorithms, I'll say, okay, this is where the container needs to be scheduled or the pod needs to be scheduled. The kubelet will then take care of scheduling the container, or the pod rather, and then there's a proxy which allows you to talk to the service itself. From the client side, you have a client that makes a request to the load balancer, and then it gets balanced between, it goes and talks to the service, which then goes and talks to the pod, and then returns a response back. So the master is not a single point of failure from the runtime perspective. It could be a single point of failure from the administrative perspective, but there are ways around that. So this is my Kubernetes cluster. Now, kubectl is a CLI, as we talked about it briefly. This controls the Kubernetes cluster manager. I can, all the terminologies that are available for kubectl for a single node or a multi-node stays the same. So I can say, get me the list of pods, or create this resource, update a resource, or resize the number of replicas in a particular replica set. What are my options for running Kubernetes on AWS? There are quite a few, actually. If I were to run a single node cluster, just like Docker for Mac, I got Minikube. So Minikube is a hypervisor VM, which I can run on a Mac, and it just runs very efficiently. So I can do all my development using Minikube, and that's indeed my development environment. If you were to run a multi-node cluster on AWS, then kops is sort of the standard way that Kubernetes community is promoting. And for now, it's a separate project. Go to github.com/kubernetes/kops. Think of kops, like if you look at kubectl, from a user perspective, it creates those resources for you. Think of kops as kubectl for clusters. It can do the same thing to clusters as well. So kops is one of the ways. Then there is kubeAWS, which is still a Kubernetes incubator project, which allows you to create the Kubernetes cluster as well. And literally this morning, I was having discussion with some folks on sort of the design pattern. When would I use kops versus kubeAWS? And then there is a Hept.io offering. These are the guys who were the original founders of Kubernetes. They left Google and they started their own company, and they have created a quick start template or a CloudFormation template on AWS on how you can easily fire it up. Not on AWS, but there are other cloud offerings as well. So before we jump in there, let's take a look at it. How do we get started on this? I'm going to take the questions at the end of the session, actually. So I'm going to GitHub Kubernetes kops here. This is my project, and if you go here, it kind of gives you a nice explanation. It's got a nice graphics here by ASCII art, so that's pretty cool. It talks about what features it offers, how do you get started with it. I'm literally building I blogged about it already, of course, but the steps have a little bit simplified since then. So I started building a gist, and I'll share more details on that soon. But essentially, it talks about what are my multi-node offerings here, and how you can do using kops, kubeAWS, etc. But the key part that we're looking today is how can I set up a multi-node cluster using kops. So what I'm going to do is I'm going to go to my blog. The steps for running Kubernetes cluster are a bit involving on AWS, and one of the things that I'm looking at is how can we simplify those steps. So one of the things I'll be working with the Kubernetes community is really simplify those steps, dumb down those steps. And while it's trying to load it here, Let's see how my console works here. So let's cancel it here, okay? It's gonna show me all the nodes that are available. I'm gonna actually switch zones. I'm gonna go to the Oregon zone here. Well, while my blog loads up, so what I'll show you here is, I have created a 6-node cluster here. So let's do this way. I'm gonna say name, and I'm gonna say star Kubernetes star, okay? Oh, no, we didn't like it. Well, let's look at the instances at the bottom here, for example. Let's see if the blog has loaded. Nope. Not loaded yet. So essentially, I've created a 6-node cluster here. And one of the beauties over here is how, when you create a cluster using kops in the CLI, you can start specifying, oh, by the way, yes, I'm creating this cluster in so-and-so region. But when you are creating the master, make sure the master is highly available. And by highly available, it says, all right, in the region, tell me what availability zones is where the master need to go. So it'll accordingly set up your masters. So if you look here, for example, I got my 1, 2, and 3 masters here. And if I look at the availability zone, they are in US West 2A, 2B, and 2C. They are actually spread across availability zones. So it kind of gives you that true high availability indeed. And similarly, my workers here as well are US West 2A, B, C. And you can see sort of my image sizes or image instance types essentially for the Kubernetes cluster. If the blog shows up, yeah, it is right here. It kind of gives you the complete details. And I wrote this blog a few months back, actually. So I was happy that the blog is still mostly working. All the steps in there work pretty well. So it kind of goes you in the detail of what do you download, how do you create a domain, and under what domain you need to register it, and how do you add your NS server records. So it kind of goes in complete detail on how can you set up a cluster. And then in terms of taking it from your development environment to the production environment. Well, you have been using kubectl as your CLI, and if you use kubectl as a CLI, you just guide it where the cluster needs to be configured to. Essentially, end of the day, your configuration is stored in a configuration file on your local laptop, and you just change the configuration, and then accordingly, it will start, the kubectl, which is your CLI, will start talking to that specific cluster. All right, the third orchestration framework that I'm going to look at is ECS, which is Amazon EC2 Container Service. So what does the EC2 Container Service offer you? Well, the biggest difference with Docker and Kubernetes is EC2 Container Service is a managed service. You don't need to create a cluster by yourself. It is a fully managed service by Amazon. So what that means is whatever your development environment is, like if you're developing using ECS, that is actually your production environment as well. So there is absolutely no impedance mismatch between your dev, staging, and production environment. So that's pretty cool. But at the core, it offers 3 capabilities. It offers full cluster management capabilities for you, where you can say, I want to set up a 6-node cluster. Sure, I can set up a 6-node cluster, and it walks you through that entire step on what the cluster should look like. Then after the cluster management, it also offers you container orchestration. In the sense, and I'm going to talk about the concepts, but when the container needs to run, can it run wherever ECS decides it to run? Or is there a placement strategy that I need to follow? Or is there a stickiness that I need to follow? So those are some of the aspects for the container orchestration that ECS handles well. And the fact that it is from Amazon, it has a very tight integration with the rest of the AWS stack. And in terms of how IAM roles could be used, how Audit Trail can be used, how CloudWatch can be used. All of those concepts are very well integrated within the ECS stack itself. Now, I talked primarily about the container service here, but another component of ECS is also the EC2 container registry. So let's say you wanna stay within the AWS stack, then you can say, I'm gonna build my image, and then I'm gonna use that image, or rather push that image to EC2 container registry. That is entirely possible. Think about building your entire CI/CD pipeline where you check a code into GitHub. With each GitHub trigger, it automatically builds an image using AWS code pipeline, which then pushes the image to EC2 container registry, and then the EC2 container service can pull that image and run the container right there itself. So how does it work? Well, at the end of the day, you are spinning up a cluster. Those clusters actually map to EC2 instances. So if you spin up a 4-node cluster, behind the scene, it runs 4 EC2 instances for you. On the cluster, you could say, I'm gonna go run a service, a database service, or an application server service, or a web server service, whatever service. A service is defined as a JSON configuration file, and then you say, I'm gonna run a service. In the service, you can define how many replicas of a container I want to run. Now, as opposed to using container, the concept here is task. Think of task as something similar to a pod in Kubernetes. So you can say, I want to run a task, and then in the service, you can start defining how many replicas of the task you want to run. And in the task, you define the properties that are relevant to a container. Things like port, things like volumes, all of those are defined in the task definition. Now, this is the diagram from the ECS developer guide. So if I can walk you through this let's see. Nope. Okay, well, I'll walk you through this here. So if you look at the key components here, so here, let's look at this box first, okay? This is one availability zone, and this box is the second availability zone. So these are 2 availability zones within a region. So as I said, because it's very tightly integrated with the rest of the Amazon infrastructure, when you say, I want to spin up a certain number of instances, those instances are automatically spin up across availability zones. So it automatically senses the availability zones and gives you high availability. Now, you could set it up within a VPC, within your own virtual private cloud, or you can say, you know what, create my own virtual private cloud. Both ways are possible entirely. End of the day, you have a task definition and a service description. A service description would say which task you are referring to. And that is what you deploy to your ECS cluster. Each ECS node, so to say, or the EC2 instance, has an ECS agent running, which is basically used for coordination across the cluster. Now, you can also have a container registry here, and that container registry is where your images would be stored and can be downloaded from. It does not have to be EC2 container registry. It can certainly be Docker Hub or a completely self-hosted registry. So AWS, in that sense, provides that pluggability. So essentially, you take your service definition and you say, go take that service definition, deploy it into the cluster, and that service definition will have the number of tasks that need to be deployed, and it will spin up the task across the cluster. Okay? So before I get into the demo, let me talk about how deep the integration with AWS is. So for example, one of the cool features is how you can take an IAM role and attach it to, say, the containers in a particular task can be run only in that IAM role. And you can make that per task specific. So that's pretty cool. Then you can say the services can deploy and scale very quickly, and they're very easily extensible as well. In the sense, you can start saying, every time I do a git push, that can then trigger a deployment using a CI tool into the ECS cluster itself. Now, as we said, if your service is running in ECS, you can easily integrate with CloudWatch, that, okay, all my logs are going to go to CloudWatch. Based upon that CloudWatch, you can set up alarms, and you can set up your service to scale up or scale down. That can be done. Auditing can be very easily done because it's very well integrated with CloudTrail, that which user tried to access which resource at what point of time. So there is a full auditability aspect that is available to you. And another important aspect of this is how you can define routing rules based on content. And that can be done using application load balancer, essentially. It's not ELB, it's an application load balancer, basically saying that if a request is coming in and looking at the request, I can route the request to the right service that is running within my application. So that makes it very interesting on how you can easily dispatch a bunch of services and then a request coming in to the right service. All right, before we get into Mesosphere, let's take a look at the ECS cluster itself. Now, the way to start with the ECS cluster would be, I will go into my console. I'm into my console here. I can just say, search for EC2 Container Service. And there comes my EC2 Container Service here. I have a cluster running already, but we'll get to that in a second. But let's say, what is my process to create a cluster here? So I'm going to create a cluster. I'm going to give it a cluster name. Let's say we use the same name as GIDS here. I can create an empty cluster. That means there is nothing in the cluster. But typically, you would want to have something in the cluster to begin with. But here, I can say, OK, what are my EC2 instance types? So I want each. Now, this is a very homogeneous cluster. So I'm saying each EC2 instance in the cluster would be of the type M4. I can say the number of instances that I want. So say a 5-node cluster. And I can just specify that number over here. OK? Here, I'm using the Amazon optimized image, or AMI. But you are welcome to bring your own AMI as well. But then, in that case, you need to install the ECS agent, which is required for coordination across the ECS cluster, which is an open source project. You can define key pair, if you want to attach yourself or SSH into the EC2 instances. Then here are the options for creating a new VPC. I can specify a security group in case I need to poke certain holes that, OK, I'm running a Wildfly server over there. The Wildfly server needs to be available at port 8080. And so let me create a new security group and poke a hole in the firewall. You can specify the specific IAM role or let it take the defaults. And that's it. You click on Create, and it runs the CloudFormation template behind the scene. And your ECS cluster is ready to roll. So I have the cluster running here. If I go back to my EC2 instances, there you go. This is also running in the US West 2 region here. And let's sort this on name again. OK, so these are my ECS instances here. So you can see that these are all my ECS instances. Yes, there is a manager which is highly available and all that stuff. You don't need to know about it. From your perspective, you're just running a 5-node cluster. And that's it. OK? Of course, this is AWS. So there is AWS console, which gives you the entire functionality. But there is a AWS CLI, which allows you to create and manage this cluster as well. Now, in this case, as you can see, my node is spread across multiple availability zones. The cluster that I created earlier, now this, I showed M4, but in this case, the cluster I created is using M3 medium. Okay, and this is my public DNS for a particular EC2 instance here, and it says the key name that is over here. So if I need to attach to that EC2 instance, I'll literally just grab this IP address, use the key which is saved locally on my laptop, and then I can SSH into the instance and for more debugging and stuff. And that concept is very much applicable to the rest of the frameworks that I showed as well. So whether it's Docker, whether it's Kubernetes, whether it's ECS, behind the scenes, they're all running EC2 instances. And the beauty is that just like any other standard EC2 instance, you can specify the key and then say, I want to be attached to it. All right, so the last orchestration framework that I want to talk about is Mesosphere. Well, Mesosphere is the company behind the framework, essentially, but it's Apache Mesos. Now, Apache Mesos was a research project in Berkeley, and that's where it was started. But essentially, it's an open source cluster manager. It was developed at UC Berkeley by Ben Heinemann, who was one of the research students who wrote the paper for Apache Mesos. The project was created in 2009. There was no Docker, no containers, none of that around that time. So the project, in that sense, has morphed to start supporting containers. But the original idea was to provide resource isolation and sharing across distributed applications. Think about this, you have a huge set of EC2 instances available to you. And then you want to provide that as an aggregate resource to some frameworks that are running on top of it. So you want to abstract, whether it's running on Amazon or a different cloud platform, you want to just say, hey, by the way, I have these resources, you want to use these resources, let's make a deal. So this way, this allows you to run distributed systems on the same pool of nodes all across. And I'll show you examples. So I could run like a Hadoop or a Spark or a Jenkins or a database server or an application server. It doesn't matter. They have abstracted the concept of what a framework is. Now, when we talk about framework, we think of JavaScript or Spring or something like that. But they're talking at a very different level what a framework is really. It also provides you cluster monitoring, just like any other framework that we talked about. And then it's using task isolation is done using Linux containers in the background. So this is the Mesos architecture that is part of the white paper that was published, and the link is at the bottom of the screen here. So if you're interested in the paper, I would encourage to go to the link and read more about it. The slides of this I will tweet right after the session as well. But from the concept perspective, on the top right, what you got is a zookeeper quorum. So that zookeeper quorum is required to make sure that, okay, if I have multiple masters, I can select a leader, and that's going to be my primary master. So that's sort of my zookeeper quorum on the top. Then, of course, we talked about how we have multiple masters. There is one primary master, and then there are other additional standby masters. On the bottom, what I got is a bunch of slaves. Those slaves could be on AWS or on a different cloud provider, it doesn't matter. But from our perspective, we'll talk about AWS. So I have Mesos slaves over there. Now, before I get to the executor part of it, on top, what I got are different schedulers. So I could have a Hadoop scheduler or a Spark scheduler or a Marathon scheduler. Marathon scheduler is the way how they run, allowed to run Docker containers in Mesos, for example. So I'll talk about the detailed process in a second, but the idea is that the Mesos slaves has a bunch of resources. Those resources are made as an offer to the schedulers, and schedulers accept the offer, and then they say, okay, go ahead, run this particular task on the slave. So how does that entire flow work? Well, I have a zookeeper quorum. Now, they recommend you to run 1 to 3 instances just for high availability. They elect a single master, and then there are a couple of standby masters. I got slaves at the bottom. This could be completely a heterogeneous cluster, so all different sorts of capabilities, but their capabilities are aggregated at the master. So for example, let's say there are 2 M3s and 2 M4s, but from the master perspective, it's going to aggregate that capability and it's going to put a data plane on top of it. That, okay, here's my data plane, and that's the eye level that I'm talking about. And then on top, what you're running is a bunch of frameworks. Could be Marathon. They even talk about running Kubernetes on AWS using DCOS. Why would you do that? I don't know. I would rather run Kubernetes as it is on AWS. But there are a bunch of frameworks that are available. And those frameworks are actually running executors in the slaves at the bottom. And within the executor is where you have a task that is running essentially. So lots of different abstractions that you need to put your head around. But once you put your head around, then you can get going on this. So here I am on my, what are frameworks? Well, frameworks are targeted at a specific use case. So think about Hadoop, think about Spark, think about Marathon. Marathon is particularly targeted at Docker containers. They're very domain specific. So the master node, because it has an aggregated view of the slave, it offers resources to each framework. It makes an offer that, hey, you know what? I got 8 GB of memory and I got 4 CPUs. You got anything to run on that much resource? The framework accepts the offer that, yeah, I got 4 containers running. I need to run 4 containers. I accept the offer, and then it passes on the definition to the master, and then the master figures out where these offers are accepted, and then it kind of dispatches it in the underlying cloud, so to say. Framework, in turn, has a scheduler and an executor, and then scheduler registers with the master for the offer, that, okay, offer accepted, and then the executor is the one that is responsible for actually running the task on the cluster itself. So let's take a look at it a little bit more graphical detail. So I have a framework on the top, 2 frameworks on the top. There's a Marathon, there's a Kubernetes. They have 2 jobs. Each of them have 2 jobs to be run. In terms of Marathon, these are essentially your Docker containers that need to be run. There is a scheduler in the Marathon framework, essentially. And then in the master, there is something called as the allocation module. Okay? So how does it work? From the slave, an offer is made to the allocation module that, oh, I got 4 GB, 4 CPU, I got 4 GB, 4 CPU. So from the master perspective is 8 GB and 8 CPU. Then the master may decide how it's going to make an offer to the frameworks. It can, as it is, pass those offers to the scheduler, of the framework, and then it might say, oh, by the way, yeah, I would like to use not the entire offer, but part of the offer. And then here are the jobs. So it's going to give the job description to the scheduler that, okay, this offer accepted, and here is the job description that you need to schedule over there. And then those jobs actually get scheduled on the right host accordingly. Now, in our case, the slaves are running on AWS, but they could run on a different cloud as well. If there are any offers remaining, it can offer those to the other scheduler. So how does DCOS, well, we talked about the Mesos concepts of it. If you were to run a Mesos cluster by yourself, it's pretty painful. You need to fire up Mesos, you need to configure DCOS, a Zookeeper cluster. In Mesos, again, you need to set up master and slave and SSH. There's a lot of configuration happening to my taste over there. I don't want to be spending time doing all those boring things. So in that sense, Mesosphere, the company which provides commercial support on Apache Mesos, essentially, they built a CloudFormation template. There are 2 varieties of the CloudFormation template. There is a basic template and there's an advanced template. Basic is typically what I'm generally using. But it's very easy to get started. It's an opinionated framework, opinionated CloudFormation template in the sense I don't need to worry about the details. It says, yep, we know what the operating system you want, we know what size you want, and we're going to fire it up. So there are some basic capabilities available. Yeah, I mean, it's good for my demos and testing and simple production deployments, limited customization options, but I'm okay with that. And if I want to go fancy, and if I want to start customizing it to a detail, then there is an advanced template available as well, which is a CloudFormation template. Then you can start saying, oh, by the way, I don't like the operating system that you're using. I'm going to bring my own operating system, or I got licenses, or I want the instance types to be such and such. So there is definitely more setup involved, but that is entirely possible. So before we go there, actually, so what I'm going to do is I'm going to go to dcos.io, and I'm going to click on install here. And here it shows you all the options. So these are all the different clouds that is running on. I'm going to click on AWS. And here is the basic and the advanced template that we just talked about. I can click on basic here. And then it shows me sort of the different CloudFormation links. I can set up a single, remember this is basic, so the options are predefined for you. So I'm running a single master and a 3-master cluster here. And I can literally click on any of the launch stacks in the right region. So for example, let's see, the nearest region for us would be Singapore, I think. So if I click on, say, a single master cluster here, the right region is automatically configured for me. The template URL is specified here. I can click on next. I can give it a name here. I'm going to use the same name as GIDS, for example. I can use a key name here. Oh, this is not right. It should be a drop-down box here. I don't want to remember my key names. So that could be a bug for the template here. But then DCOS has this concept of a public slave and a private slave. So public slave, anything you run on the public slave is publicly accessible. Everything else by default is privately available within the DCOS cluster. And there are reasons for that. For example, you may not want to put your database on a public slave instance. You may want to keep it only in the private slave. Whereas when you're running a web server, then you may want to run it on a public slave. So there are reasons and design patterns around that. So you choose the values here, keep going. It shows you different options, and that's it. You click on create, and it creates the DCOS cluster for you. And once again, as I was saying earlier, I have a cluster running here. So I think that's running in the Northern California region here. Now, one of the things I don't see here is, for example, it doesn't give me nice names here for the cluster node. Now, that would be a nice usability. So I'm seeing that I've already found a couple of bugs that I'm going to file on the DCOS.io website. But essentially, these are all my master and the worker nodes over here. It gives me the public IP address here. And I did not configure the key in this case. So I have no way to kind of log into the EC2 instances. But essentially, if I look at this one here, oh, actually, I should look at my CloudFormation template. So if I go to the CloudFormation template, and I select DCOS here, and I say outputs. In the outputs, it shows me sort of what is my DCOS DNS address. And if I take this here, and I paste it, this is going to fire up my cluster. Now, there are a few steps required before this, which I'm not going to do here, because it does require you to configure your DCOS CLI and create an OAuth token using a particular Google account and things like that. Yeah, I think it's trying to do the login here. I don't know. It's taking forever. But sort of, this is the way you create your DCOS cluster. So here, for example, I can sign in with Google now. And so this is my DCOS dashboard right here itself. Now, in the dashboard itself, if I look at the different services, of course, none are running. But in the dashboard, for example, you can see it says total 24 CPUs are available, none allocated. Total 82 gigabytes is available because we're running a variety of nodes in the background. Total disk allocation is 208 gigabytes. So the point being, you are running multiple nodes in the background, And you're getting a consolidated view of all of that together, which can then be utilized to run your services over there. And if I look at the specific service here, no services are running over here. I think they might have changed this again. I know there were discussions around changing this interface. This is 1.9. So I played with 1.8, not with 1.9. But I don't know where exactly I would deploy. It's not very intuitive to me. If I click on services, maybe deployment, services, run a service. Oh, there you go. So yeah, that's again, the interface has changed here. So essentially, here I can deploy a single container. Now, one of the disadvantages of DCOS is it has no local development environment. If you talk to the Mesosphere team, they'll talk about, yeah, we can use Vagrant. Vagrant is not really a local development environment. Imagine running a multi-node cluster on a Vagrant environment on your MacBook, which is 8 or 16 gigabyte. It completely comes to a crawl. So don't even try it. I've tried this, I've failed it, and I'm just giving my opinion here. But yeah, I think those are sort of the 4 frameworks, and that's pretty much my last slide here. The latest version is actually checked in here. So if you want access to the slides, all the slides are available over here. Those are the slides I used, and I believe the session is recorded as well. So you will have access to the recording. So we just have about 5 minutes. I'm going to wrap it up. I'm going to get off the stage, and then I'm available for questions. Thank you. I'll take the questions off the stage here. Yep, that's it up. Thank you.